Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing momentum for extended candidates only, part 2. Kindly before we start, you can go and check part 1 and you can go and check playlist. You will find notes related to momentum. Let's start question 8. Okay, we have an air pistol fires a pellet forwards. What is the motion of the air pistol? If you draw here gun, rifle, air pistol, whatever, you will imagine how this is gun, okay, and you have here small pellet, we can imagine or we can consider the mass of the gun, m of the gun, v velocity of the gun, here mass of pellet, and v velocity of pellet. In this case we don't have collision, we have what we call it explosion. So we can rewrite the principle of conservation of momentum, but in case of explosion, total momentum before explosion is equal to total momentum after explosion. This is number 1. When you substitute, you will write down here mass m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Before explosion we don't have we don't have initial velocity, so this term will be 0, and here we have mass of the gun, velocity of the gun, plus mass of the pellet, velocity of pellet. If you rearrange, you will find that mass of pellet, velocity of pellet is equal to negative mass of the gun, velocity of the gun. Okay, this negative sign indicates that the gun recoils or moves backwards in opposite direction to pellet. Here mathematically we are using our mathematical skills and we are rewriting the principle of conservation of momentum, so we have this conclusion. But also we can explain this according to Newton's third law of motion. Here we have an action and reaction. When the pellet gains momentum in one direction, it moves forward. It moves in this direction, okay? What is the reaction? The gun recoils with momentum in opposite direction. So the movement of the gun is backwards. So we have to exclude now C and D. So the air pistol or the gun moves backwards. Still, we have to discuss if the speed of the air pistol or the gun, is it greater or smaller than the speed of the pellet? If you look at this equation, this final equation, okay, you can recognize that mass and velocity, they are inversely proportional. Which object here, it has greater mass? Yes, very good. The gun, it has greater mass. So its velocity will be less. So the correct answer, the air pistol moves backwards and its speed less than the speed of pellet. Is it clear? This question is challenging and is very important. Question 9. We have here collision. A ball of mass 0.16 kilograms is moving forward at a speed of 0.50 meter per second. A second ball here, mass 0.10 kilogram, smaller, is stationary, at rest, not moving. The first ball strikes the second one, so the second one moves forwards at a speed of 0.50. You can draw or sketch here to imagine what is happening. We have here 0.16 kilogram and the second one stationary, 0.1 m2 is equal to 0.10 kilogram. U2 is 0, stationary or at rest, and the first one is moving forward. This is forward. So you have here U1 is equal to 0.50 meter per second. This is before collision. What happens after collision? After collision, the first one moves at a speed v1. You have to find v1, okay? And the second ball moves forward at a speed v2, which is 0.50 meter per second. So this is after collision. This is M2, this is M1. As usual, you have to substitute M1, initial velocity U1, plus M2, initial velocity U2 is equal to M1 V1 plus M2 V2. Okay? When you substitute here, you have the mass of the first one, 0.16 kilograms. Check that you have consistent units, times U1, which is 0.50, plus M2, here U2, since the second ball, it was stationary, so all this term will be 0. M1, 0.16, V1 is unknown, plus M2 V2, you have to substitute the mass of the second one, 0.10 times 0.50. Simplify, you have here 0.08 is equal to 0.16 V1 plus 0.05. Rearrange, so you have 0.16 V1 is equal to 0.03. You have to find the value of V1. V1 is equal to 0.1875 meter per second. The choices you have here, 0.19, so the answer is B. Okay, let's draw before and after collision. So here we have the coconut is somehow heavier, it's 0.48 kilograms, so this is the coconut. And you have here the soft object, which is 0.12 kilogram, we consider it M1. U1 is the initial velocity, which is unknown, the minimum speed with which the visitor should apply or should throw the soft object in order to dislodge the coconut. So this is unknown. Okay, this is before collision, and before collision we consider the coconut at rest, so U2 is equal to 0. So this is all takes place before collision. What happens after collision? After collision, the coconut moves or 0.48 kilograms. So V2 is 0.10 meter per second. It's given here to move at 0.10 meter per second. And V1 will be 0 meter per second. The first object, the soft object, will become at rest. Okay, so right here, this takes place after collision, applying the principle of conservation of momentum. Please write down V1U1 plus M2U2 is equal to M1V1 plus M2V2. Okay, we have two terms here will be equal to 0, which is the coconut before collision, so this is here 0, and the soft object after collision, so here this also will be equal to 0, and then substitute M1U1, so you have 0.12, the mass of the soft object, times U1, which is unknown, and here M2V2, the mass of the coconut, which is 0.48 kilograms. Check that you have consistent units, times V2, which is 0.10 meter per second. When you simplify, 0.12 U1 is equal to 0.048 so U1, the initial velocity, is equal to 0.4 meter per second. You can choose the correct answer here is B. Question 11, it's a challenging question. We have here a tennis ball of mass 0.060 kilograms travels horizontally at a speed of 25 meter per second. Since the question is telling you speed, it means you have the magnitude of velocity. So the direction is not mentioned. You have to follow the diagram and you should find the direction of velocity. So 25 meter per second, it's the magnitude of velocity. The ball hits a tennis racket and rebounds horizontally at a speed also 40 meter per second. So speed 40 meter per second, it's the magnitude of the velocity. It's not the velocity. So you have to consider the directions. You have to pay attention. If you have opposite direction, you should follow the rule we apply, that you have to put the negative sign. The ball is in contact with the racket for 50 ms. What's ms? Millisecond. So first of all, we have to convert, because here we don't have consistent units. We have speed meter per second, but we have the time in millisecond. So you have to convert millisecond to second. Okay, so we have here millisecond to second. So the prefix milli, you have to multiply by 10 to the power of negative 3. So you have 50 millisecond times 10 to the power of negative 3. So your answer will be 0.05 seconds. Is it clear? Okay. So this is the first step. Calculating the force does the rocket exert on the ball, but you don't have the mass of the rocket. So we consider Newton's third law of motion. For every action, you have equal and opposite reaction. So every action has an equal and opposite reaction. So we consider the force exerted by the rocket exert on the ball will be the same magnitude as the force exerted by the ball on the rocket. Okay? So when you substitute here, you have only the mass of the ball itself, and we don't have the mass of the rocket. So we are calculating here the force. When you substitute, you have 0.060 times delta V, the change in velocity, divided by time taken for this change, which is 0.05 seconds after conversion. When you substitute, you have to follow the rule or the concept. Velocity is a vector quantity. It has magnitude and direction. Okay, so delta V here we have V final minus V initial. V final minus V initial. V final, you have V final here is 40 meter per second. It's the magnitude of velocity. What about the direction? It's in opposite direction to initial velocity. So when you substitute final velocity here, it will be negative 40. And still you have here the negative sign minus here. This is not negative, this is minus. The subtraction, V final minus V initial. What about the initial velocity? Initial velocity here is 25. Simplify, the force will be 0.060 times negative 65 divided by 0.05. The final answer will be negative 3.9, 0.05. Your answer is negative 78 Newton. Okay? Why is it negative? According to, so this negative, according to Newton's third law, because it's a reaction force. Reaction, due to reaction. According to Newton's third law of motion. For every action, there is an equal and the opposite reaction. The action is the tennis ball is hitting the rocket. The reaction is the rocket is exerting an opposite force equal in magnitude, but it's in opposite direction on the ball. That's why we have here a negative sign, but the choices we have, the answer is D, because here is asking you about the magnitude of force. Substitute M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Since they stick together as one object, so we consider now they have combined mass and they have they have common velocity. I will remind you, as we said earlier in previous questions, the driver sitting in the car, although he is sitting, but he has the same speed as the moving car. Now they are moving as one object. They are moving as one object. Okay, so when you substitute here, m1 0.50 times 3 plus 0, it was initial velocity here, q at rest. Rearrange. So when you substitute here m1 plus m2, let's write it directly. It's 0.50 plus 1 kilogram. Check you have consistent units. So when you substitute, you have 1.5 is equal to 1.5 V. So it's clear that V is equal to 1 meter per second. 1 meter per second is the magnitude of velocity. How can you know the direction? If they move forward in this direction or they move in opposite direction. You have here choices. Since you have here your answer is positive, not negative, so it means the same direction as P was traveling originally. So the correct answer is A, 1 meter per second in the same direction as P was traveling originally, because your answer is positive. If your answer is negative, so it will be in reverse direction to the direction of P was traveling originally. Is it clear? Since your answer is positive, so it will be in the same direction. Here m1, u1 initial velocity, u2 is equal to m1 v1 final velocity plus m2 v2. Okay, when you substitute here, you have the initial velocity for the first object is, its mass is 2, its initial velocity 12, check you have consistent units. The second object at rest, which means its momentum 0. Total momentum after collision, you have here, they will stick together and act as one object. So you have here combined mass and you have common velocity. So their masses will be 2 plus 3. Simplify. So you have here 24 is equal to 5V. V is unknown. You have to calculate the final velocity here is 4.8 meter per second. So you will exclude B and exclude D. So their final speed is 4.8. Okay, you have to choose between A and C. The total momentum. You can calculate the total momentum before or after, right? Okay, don't use numerical values you already calculated in the steps to get your final answer, like the common velocity after collision. This answer is your answer. It's not given in the question. So I prefer if you can use total momentum before collision. Why? Because before collision you have the numerical values already. So total momentum before collision, this one, 2 times 12 plus 0, so it will be 24. So the total momentum before collision or after collision, I know that they are the same, but if you calculate using V, maybe your V or your calculations are not totally correct. So the total momentum before collision is 2 times 12 plus 0, which is 24. Question 14. We have here the momentum of a body is changed by force acting on it for a period of time. Which action increases the change in momentum? If you write the equation we are using to calculate momentum, that force or change increases the change in momentum, not momentum, the change in momentum, you have F delta T is equal to M delta V. Okay, so here this term is representing the change in momentum. Okay, let's discuss all the choices we have. If you double the force and the time is halved, what will happen? If you double, write it in different color. If you are doubling the force and the time is halved, okay, so they will be cancelled out. So you have still you have the same change in momentum, 2 times half, so the answer is 1. So you will get the same change in momentum. He is asking you about which action increases. You want to increase. Okay, so the first one is not correct. Okay, let's check the second one. Doubling the force for the same time. If you double the force and still you have the same time, no change in time, yes, this is correct. This is correct one. You will increase, the change in momentum will be also doubled. Let's check C and D. If force and time, both of them, they are halved. So if the force here will be half and the time halved, so you will get quarter the change in momentum. So also this one is not the case. You are trying to increase change in momentum. So here this one is not correct. The last one, if the time is doubled and the force is halved, this will be the same as A. If the time is doubled and the force is halved, so half times 2, it will be 1, so you will get the same change in momentum. So also this one is incorrect. So the correct answer is B, doubling the force at same time, or maybe doubling the time at the same force will give you the same effect. So increasing the change in momentum, you can double the force for the same time. Okay, so this is question 14. The last question we have for classwork, question 15, is challenging and very important. We have a comparison here between an electron and a neutron. We have the speed, we have masses. Pay attention, guys. When you have masses here are given as a ratio, it will be better to answer or to write down your answer as a ratio also. Okay, so you are comparing which row is correct, greater momentum and greater kinetic energy. So we are trying to calculate it as a ratio to find your answer as a ratio. So the momentum, you know, the momentum P is the momentum of the electron to the momentum of neutron. So it is mass of electron, velocity of electron, divided by mass of neutron, velocity of neutron. Okay, when you substitute We have here mass of electron is m times velocity, which is 5 times 10 to the power of 6. We have here mass of the neutron is 2000 m times velocity, which is 5 times 10 to the power of 4. Okay, don't use your calculator, you will waste your time. It's much more better when you use your mathematical skills. Okay, your skills. It will be easier to cancel out here. You have 5 and 5. When you are dividing, you know that you have the same, when you have the same numbers, here you have 10, you have the same base, sorry, so you can subtract your exponents. When you are multiplying, you are adding exponents since you have the same base. So when you simplify this, you have the answer is, when you have 10 to the power of 6 and 10 to the power of 4, subtracting here the exponents, so the answer will be 10 to the power of 2, so the answer is 10 to the power of 2, divided by, here you have only 2000. Your answer will be 1 over 20. So the ratio between the momentum of electron to the momentum of neutron, if you rearrange it, so you have the neutron is equal to 20 times the momentum of electron. The momentum of electron. So which one is greater? The momentum of neutron is greater. When you are trying to calculate the kinetic energy, so also kinetic energy of electron to the kinetic energy of neutron as a ratio, you have half mv squared for electron, half mv squared for neutron. Okay, when you substitute, you have here the half will be cancelled out. You have m times also 5 times 10 to the power of 6 squared. You have here 2000 m times 5 times 10 to the power of 4 all squared. So when they are cancelled out, okay, 5 squared and 5 squared, so the final answer you have, it's 10 to the power of 6 all squared, it's 10 to the power of 12 divided by 2 times 10 to the power of 3, which is 2000, times 10 to the power of 4 all squared, which is 8. Simplify, so you have 10 to the power of 12 divided by 2 times 10 to the power of 11. Your answer is 10 divided by 2, which is 5. So the ratio between the kinetic energy of electron to the kinetic energy of neutron is 5. If you rearrange, you will find that kinetic energy of electron is equal to 5 times kinetic energy of neutron. So which one is greater here? If you compare, the kinetic energy of electron is greater and the momentum of neutron is greater. So your correct answer is C.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.